We're going to use the root test to determine whether this series is convergent or divergent. So with the root test, we take the limit as n approaches infinity of the nth square root of the absolute value of a sub n. If this is less than 1, then it absolutely converges. If it's greater than 1, it diverges. And if it equals 1, it's inconclusive. So with our thing, we have a sub n as that thing right here. So a sub n equals n squared plus 1 over 2n squared plus 1 to the n. And remember that we were looking at our absolute value to be taken to the nth square root, and then the limit as n approaches infinity of that. So our absolute value of this, what's that? Well, it's the same thing because it's positive anyway. All terms are positive. So that's what we have. Now we can take the nth square root of this and take the limit as n approaches infinity. The nth square root and the limit as n approaches infinity. What this causes is this exponent to go away. And so we're left with this. Now we could just go ahead and divide everything by n squared, because we have n squared here, n squared there. Divide everything in a numerator, everything in a denominator. We're left with 1 over n squared. And we're left with 2, because we divided by n squared, plus 1 over n squared. We divided everything by n squared. Now we plug in infinity wherever we have an n, and this goes to 0, and that goes to 0. So we're left with 1/2. 1/2 is less than 1, so this absolutely converges. It absolutely converges by the root test.